Alright, so for the first part of 7.4, you need to know how to do a few basic things, and it's basically all algebra with trig. So for example, the first part is simply adding, subtracting, multiplying, and dividing trig expressions. And you're going to do exactly what you would expect you would do. So for instance, if we have 3 sine theta cosine cubed theta minus 12 sine theta cosine cubed theta. Okay. And now let me illustrate how easy this is. This may seem a little weird, so a good way to think about it until you recognize that it's not so bad is that it's just like if I had 3sc cubed minus 12sc cubed. How would I yeah, so this is just negative 9 sc cubed, which s was really a placeholder for what? So negative 9 sine theta, and then c was a placeholder for cosine, so we do cosine cubed theta. Make sense? Okay. The steps were to combine like terms.
Okay.
3 minus 12 is negative 9.
Okay.
That's it.
Oh, yours. It's like
It's
the whole thing is an X.
it's just one step, yeah.
So you're not, you just simplify.
Yes.
Oh, okay.
Yeah, easy stuff. The one thing I do want to clarify, so for the notation, if you see something like sine squared theta, what that means, like if there's an exponent in between the sine and the theta, that actually is the same thing as the sine of theta, and then the whole value gets squared. Okay? Why? Because this is less writing than putting parentheses around it and squaring it. Okay? And I think you guys will appreciate that, because if you have to write this 80 times like we will later, you don't want to have to write 160 parentheses and 2. Okay? Not to be confused with this. If you wrote sine theta squared,
The theta squared.
right, that means you're going to take the angle, square the angle, and then find the sine of that angle, which is not the same thing as finding the sine of the angle and then squaring that value. Okay, so just make sure that you understand that this and this are not the same. If we're talking about the whole thing being squared, then we could write it as sine squared theta. Okay? Once you get past that, the stuff's easy. For instance, let's say we wanted to multiply some stuff out. So if I had like 4 plus 5, let's say sine of alpha, and I wanted to square this.
Is the 5 connected to the sine?
Yes. So this is how many terms? 2 terms, right? If you need help to get started, a good way to think about this,
Wait, is that an X or a little symbol?
that's an alpha. It's a variable.
Like a letter A.
A good way to think about this, if you're not sure how to multiply this out, would be to compare it to 4 plus 5s.
It looks like 5, 5.
Do you guys know how to do this expression?
Yeah.
You should say, yeah, that's easy, right? Either FOIL it out or do the shortcut. If you do this, you get 16 plus, what's the middle term?
18s.
40s plus 25 squared. Either FOIL or remember the pattern, right? 4 squared, double both of these combined, you get 40s, and then the last term squared. So what would this be equal to? 16 plus,
40 sine alpha
yep,
plus 25 sine
Sine
alpha.
squared
Sine squared alpha.
alpha.
there you go.
Yeah,
That's alpha.
look at that. We're pros, right?
You are. Are there
Where does
any?
alpha come from?
It's just a variable.
Okay.
We usually use Greek symbols to represent angles. So you'll see alphas, betas, thetas.
Delta,
Omega is typically used for different. Omega is used for like resistance, I think.
Can we just write A?
Can you just write A? If you tell me A equals alpha, then you can do whatever you want. But if you change them without telling me what A is, then it's incorrect. Start at the bottom,
Or you can start at the top.
or you can start at the yeah, it doesn't matter. All right, settle down. I want to do this as quickly as possible, guys. All right.
Wait, why'd you draw that symbol at the wall?
Show say how to draw.
Another example.
What? Oh,
probably all numbers.
Factor cotangent squared, let's say beta, just so you guys see all the different symbols and get used to them, minus 4 cotangent beta plus 3.
What's that?
Oh.
What's that?
If anybody thinks they know how to factor it, raise your hand. Don't shout it out. Just tell me if you think you got it.
Maybe.
1, 2, 3, 4, 5, 6.
I'm still writing. Oh.
No. That's
Making sure you see my hand.
I see it. I'm waiting for more.
Are you gonna roll the die again, thingy?
Try to do it.
Raphael, you look really confident back there. What'd you get? Very good. How many of you had that?
I didn't put it on the paper.
But you knew, okay. Do you see how this is the same as what we've been doing, but now there's trig floating around in here? This is just like factoring c squared minus 4c plus 3. You guys see that, right?
Now, how do you make it more difficult?
How about we not make it more difficult?
I'm glad you asked.
Oh.
It was gonna come anyway. Come on.
Yeah, I mean,
Let's be real, guys.
look, you guys know how to factor. I mean, you should know how to factor. If you see something like cosine cubed minus 8 and you cannot factor that, that's more of an issue of you don't remember your cubes formula, not that you don't know how to use the trig stuff. No, not today, but eventually, yeah.
So questions like these, I think
Yeah.
That's why we're learning them.
No, I'm just showing you stuff just for the heck of it.
He
Okay.
teaches us stuff just because.
Actually, this is not an example. Basic identities, okay? So, look, we're going to do... I'm going to try to convince you that you already know how to do the stuff that we're going to do. Okay? And hopefully you are convinced that you actually understand where everything's coming from. The second part of the notes that we'll do at the end of class are all going to make sense. It's just going to be a little tricky at first because you're not used to doing anything like it. Okay, but this is going to be important for the second part, so we'll just get it out of the way now. Okay? Tangent theta. If I asked all of you to tell me with y's and x's what tangent theta is, you would all say,
Y over X.
okay. What about y? What is that equal?
Sine theta.
Sine theta. What about x? What is x equal? So instead of writing this as y over x, we could theoretically write it as...
Sine theta over cosine theta.
Very good.
we all erase.
So you already know this, right?
We did that in geometry.
Okay. Cotangent theta
sine over cosine.
is cosine over sine using the same ideas. Okay. You could even say that cotangent, you see that these are just reciprocals of each other, right?
Tan theta negative 1.
Or 1 over
Tangent theta.
tangent theta is cotangent. We could also say tangent theta is 1 over cotangent. These are all the same.
This is messed up.
Okay. Well, the good news is you already have these memorized. It's just now instead of using x's and y's, you're going to actually use the names.
Wait, why is it 1 over?
Tangent and cotangent are reciprocals, right?
Yeah. Sure. Yeah.
Now, secant
1 over.
is 1 over x, but we're going to write it as 1 over cosine. Ellie, what would cosecant be? One over sine. Yep. Everybody okay with where these are coming from?
Kind of.
It's just using the x and y definitions, but we're replacing x's and y's with cosines and sines. Okay. Now, big one. This is a huge identity that we'll use in a little bit. Okay. You guys know that the unit circle equation is x squared plus y squared equals 1. Unit circle equals 1, right? But what's x? Cosine. What's y? So this is the same as cosine squared theta plus sine squared equals 1. This identity is very, very, very important. It will come up frequently, and so will the other variations of this. And what I mean by variations is you could move stuff around in this equation. For example, if I got cosine squared alone, what would it be equal to?
Square.
If I got cosine squared alone,
Oh,
Negative
1 minus
It would be
sine
1
theta.
minus.
1 minus sine squared. What if I decided, well, you know what? I want to get sine squared alone. What would that be?
1 minus cosine.
Okay, so all of these are the same, and they all come from this basic identity, this big identity here. It's one of the 3 Pythagorean identities that we're going to do. Yes?
Notice this only applies at unit circle. This applies to all cosine and sine.
All cosines and sines. Because every single theta could be reduced so that it is on a unit circle. So it works all the time. Any other questions? Okay, then Kevin will walk us through this last example here.
All right.
Who's Kevin?
You, Kevin.
You Kevin.
Simplify.
Move it up.
Sorry. Using sines and cosines only. So if I start with secant theta plus 1 over cosine theta minus tangent theta, Kevin's going to tell us what to do because the directions are pretty clear. Simplify using sines and cosines only.
Okay.
So Kevin, can you tell me how to write secant? 1 over cosine theta, yep. Plus 1, we're going to leave.
Oh.
Cosine theta is already a cosine. What about tangent theta?
Minus sine theta over cosine
Good. Does everybody see where Kevin got this first change here? Now, I don't know about you guys, but we don't like complex fractions in this class. I know it's got trig in it, but technically it's a complex fraction, right? What could I do to the numerator and denominator if I don't want this little cosine that's there? Multiply. Don't whine. This is making life easy. Believe me. You're going to want to know how to do this.
In life, or
Well, for what we're doing in class.
Yeah, I thought so.
Otherwise, you're not going to... What's cosine theta times 1 over cosine theta? 1. What's cosine theta times 1? Cosine theta. Cosine theta times cosine theta is Cosine squared theta. Very good. Minus, what's cosine theta times this fraction? And we don't have a complex fraction anymore. And we got cosines and sines. This is good.
Would we want to get rid of the 1 by writing it as
Cosine squared plus sine squared? It'll overcomplicate it, but you're welcome to do that if the situation presents itself later, which it might. Okay? Yes?
Do we have to keep drawing the circle of the line?
Absolutely. Are you kidding me?
No.
This is a great question, and it's one of my biggest pet peeves. I will give you no points for any of the problems that we're going to do if your angles are missing. Let me explain.
Wait, what do you mean angle?
I know what she's talking about.
I don't know what you're
Square root of 5
Oh.
plus 3x equals 0. Okay?
Can you move it up? What kind of example?
Just go with. Just don't worry about it.
Oh.
Just watch. Okay?
Let it flow.
I got you.
Okay. Now watch. How do you get x alone here?
Minus
Subtract root 5. And then divide by 3. So x is negative 5 over root 3.
negative
Now,
5. Okay.
over here, 3x would be equal to what? Negative sine theta. And then x would just be negative sine theta over 3. Now, and I'm making a big fuss out of this because you're going to understand. If you say, well, I don't like writing those angles, so I'm just going to write sine plus 3x equals 0. And I'm going to get 3x alone, or I'm going to get x alone, right? So 3x equals sine. And then, thank you, negative sine. And then x equals negative sine over 3, right? Looks good, right? Let's compare this to what this would look like over here. The reason I'm saying let's compare that to that, when you see sine of something, it's a universal language that tells you to think of the unit circle and find the y-coordinate, and that's what that represents, right? When you see a square root of something, that's a universal symbol to everybody that tells you to find a number times itself, right? That gives you 5, or whatever the number is. Doing something like this would be like saying,
That looks good.
Really?
That's so much good.
Final answer.
Everyone, you did the
Erica just got
Can we not?
lawyer.
Can we? Yeah, okay.
okay, do you guys understand my point?
No.
I don't see how you did it, but
When I say square root,
Okay, so let's say
just work with me here. If I say find the square root, well, you would say square root of what, right?
No.
No.
Well, you should.
What the heck?
My gosh.
Just square root of nothing.
Okay.
If I say,
We'll make our
I
own.
would say 55.
like, for example, if you come in, remember we did those problems yesterday when you were standing up and I said, tell me the sine of this? And you guys were all standing up and I said, Abby, tell me the cosine.
Of?
Abby would be like, what? Cosine of what? What are you talking about? You need something in the trig functions, otherwise this doesn't make any sense. Okay?
What the heck?
Okay, so hold on. So you left out the sine theta in the example on the bottom right.
Yes. That's what I'm trying to say. Don't do
So what
this.
does theta equal? What is theta?
Theta is an angle.
The top to our right. So are you saying the number on our square root is an angle?
No, I'm just comparing. Sine is an operator. The square is an operator.
So if
Okay.
we give you an angle, would you put the number there?
Yes.
Oh,
Okay.
Right. Right.
you know what? We
You can't just do
we should
negative
just
sine
explain
over
this as x sine x.